bread and butter of algebra, solving equations. And most of you have dealt with some of this stuff in the past, but we're going to get a little more advanced as we go through this chapter. So first part, just solving one-step equations. So to solve an equation, we're just going to find what makes the variable true for that equation. And I always think, do the inverse of what's being done. That'll help you. Do the inverse of what's being done. And my other rule is, whatever you do to one side, do to the other side. When I say the other side, I'm saying the other side of the equal sign. And we'll talk about that. And our goal is to get the variable by itself. Okay, I'll repeat those things over and over as I go through problems here. So we have a couple of properties. Pretty basic. You don't really need to get these down. But addition, property of equality. If I add something to one side and I add that exact same thing to the other side of the equal sign, my equation stays balanced. That's that property. Same thing with subtraction. If I subtract one thing from one side and subtract from the other, my equation stays balanced. Same thing works with multiplication and division. If I multiply by the same thing on both sides, I keep my equation balanced. And if I divide by the same thing on both sides, what we usually write is a fraction bar, right? Let's get rid of those division symbols. Fraction bar, well, 4 equals 4, so it stays balanced, correct? So what do we do to one side? Got to do it to the other to stay balanced. So looking at number 1. H minus 12 equals negative 27. So find your variable. It's on the left side of the equal sign. So what I want to do is do the inverse of what's being done to H. Well, right now, we're minusing 12. The inverse would be adding, and we got to do the exact same thing. So instead of minus 12, we're going to add 12. So do the inverse. Whatever I do to one side of the equals, do to the other side of the equal sign. We go through. When I do the inverse, they cancel, right? So I bring down my H, bring down my equal sign, and negative 27 plus 12 gives me a negative 15. Then we're done. Same thing with 2. What are we doing to the variable? There's C. We're adding by 102, so the inverse of adding by 102 is subtracting by 102. I put it right below it. Whatever I do to one side of the equal sign, do to the other, so subtract by 102. Bring down my C. And these cancel, bring down my equal sign. Okay, and we're not too concerned about doing this mentally, so use a calculator if you'd like. We want to know that you understand the operation of, we want to know that you understand the process of solving the variable. So 36 minus 102, or 36 plus negative 102, gives me a negative 66. Negative 66. And then we box our answer. So basically what that means is if I plugged in negative 66 in for C, I would get 36 after I took negative 66 plus 102. So you can always check your answer. Looking down at 3. Well, G, the variable, is on the right side of the equal sign. Same thing happens. I just work on the right side now. So what am I doing to G? I'm minusing by 25. The inverse would be to add by 25. Whatever I do to one side, I do to the other side of the equal sign. So 113 plus 25 gives me 138 equals G. Bring that down, and these are gone. There you go. G equals 138. And I can leave it in that order, right? It's symmetrical. So it doesn't matter that the 138 equals G or the other way around. Lastly, try to confuse it a little bit, throw in a negative. Well, it's still the same thing. What are you doing to J? We're adding by negative 87. So the inverse is subtract by negative 87. Whatever I do to one side, I do to the other side. And whenever we subtract by a negative, it's really adding by a positive. It's really adding by a positive, isn't it? So those cancel right when we do the inverse. So J equals negative 3 plus 87 gives me positive 84. So whenever you minus by a negative, it's really adding by the positive. Let's work in some multiplication and division now. So I find my variable in number 1, which is B. Well, what are you doing to B? You're multiplying by negative 15. The inverse of multiplying is dividing. So we'll divide by negative 15. Whatever I do to one side, I do to the other. So my 15s cancel. I bring down my equal sign, bring down my B that's left over, and negative 75 divided by negative 15 gives me 5. Negative divided by a negative is positive, right? Remember that? Looking over at 2. Where's my variable? It's on the left side, x. What are you doing to x? You're dividing by 5. What's the inverse of dividing by 5? Multiplying by 5. Whatever I do to one side, I do to the other side. My 5's cancel over here, and I'm left with x. I bring down my equal sign, and negative 20 times 5 is negative 100. Looking down at 3. 3/5. Oh, forgot to box my answer for 2. 3/5 k equals 6. 3/5 k equals 6. Well, what am I doing to k? I'm multiplying by 3/5. The inverse of multiplying by 3/5 is dividing by 3/5. Well, if I divide by 3/5, I'm just going to write my division symbol here. If I would write that down here, 3/5 divided by 3/5. Remember, I never divide fractions. I change to multiplication. So really, I take 3/5, I change the multiplication, and I multiply by the reciprocal. So dividing by something is really the same thing as multiplying by the reciprocal. And what happens? You know, my 3's cross cancel, my 5's cross cancel, and we get 1 over 1, which is 1. And 1 times k is just k up here. So instead of dividing by 3/5, to make it easier, we're going to multiply by the reciprocal. So we're going to multiply by 5 over 3. Whatever I do to one side, I do to the other side. So instead of dividing by 3/5, we multiply by the reciprocal. Well, these cancel, so I'm left with k equals, well, 6 times 5/3. Well, 6 is really 6 over 1. And if I look, I can just multiply across. 6 times 5 is 30 over 1 times 3, which is 3. And then divide there, which is 10, right? 30 divided by 3 is 10. Or I could have cross canceled. 3 goes into 6 2 times. So it's 5 times 2 is 10. 10 over 1. So I get the same thing, don't I? But just remember, multiply by the reciprocal when you're dividing by a fraction. Same thing with 4. Except something screwy here, isn't there? I have a mixed number, -1 and 3/8 times n. So I need to change that to an improper fraction. So 8 times 1 plus 3, which is 11 over 8. Don't forget that it's negative, equals 2/3. And we just said the inverse of multiplying by -11 over 8 is dividing by that. Well, instead we're going to multiply by its reciprocal. So we're going to multiply by -8 over 11. Whatever I do to one side, I got to do to the other side. -8 over 11. So these cancel each other. We're left with m equals, well, positive times a negative is a negative. 2 times 8 is 16. 3 times 11 is 33. And I do not believe that simplifies. So we are done. Lastly, we can have to write a formula for an equation before we can solve. So Richard is driving 780 miles to Memphis. He drove about 3/5 of the distance on the first day. But how many miles did Richard drive? Well, 3/5 of 780 I don't really need to set up to solve an equation because my distance is going to be on the other side of the equal sign. Is it 3/5 of 780? So we just turn 780 into a fraction, and then we multiply. 5 goes into 780. (156 times), and 156 times 3 gives us 68 miles. That's everything. Remember, do the inverse of what's being done, and whatever you do on one side, do to the other side.